Development of the theory of punctuated equilibrium was initiated by Professor Niles Eldredge in a study titled The Allopatric Model and Phylogeny in Paleozoic Invertebrates, which appeared in the 1971 scientific journal known as Evolution. Millions of years ago, ancient seaways flooded large areas of the interiors of the United States, leaving a fossil record with millions of specimens to be dug up for study, specimens that are preserved rather well. One of the most common and easily collected specimen of the now extinct animal that lived in those ancient seas is a species known as Phacops rana. The word rana means frog in Greek. If you look at a Phacops head on, and use a bit of an imagination, its face looks kind of like a frog's. It was discovered with a lot of searching and digging that Phacops fossils occur from New York State all the way down to Iowa and down to the states of Mississippi and Alabama, back up through to New York. Scientists studying these trilobites more closely and looking at the eyes of these animals discovered that the eyes are similar to an insect's eyes, but also quite different. Within the trilobite's eyes are separate lens units, raised in vertical rows, each raised lens unit being a separate eye in itself, an aggregate of eyes, and not so much like a compound eye like you would see in an insect such as this dragonfly. Professor Eldredge, that did all the searching and digging, noticed in detail when it came to the specimens he had collected that they had 17 vertical rows of lens units within the animal's eyes. But some of the other trilobite specimens that he had collected had 18 vertical rows of lens units that made up the animal's eye. He came up with the idea of plotting on a map of the United States his collected trilobite specimens that had 17 lens units that made up the animal's eye occurred in the Appalachian Mountains and from there towards the East Coast, and that his collection of specimens that had 18 lens units within the eyes of the animal were occurring within the northern Midwest area of the country. Both animals almost exact types of trilobite morphologically, but with different numbers of raised lens units that made up their eyes. The trilobite with 18 raised lens units inhabited an environment where the water column was clear to some degree, and the trilobite with 17 raised lens units that made up its eye inhabited an environment that was muddier with more silts and sediments suspended within the water column. Then at one point, the inland seas in the Midwest area of the country receded, driving to extinction the earlier form of trilobite that had 18 lens units. When the sea returned, the trilobite with the 17 raised lens units colonized the area previously inhabited by the now extinct trilobite. The trilobite with 18 lens units that made up its eye also occurred in an isolated pocket to the east within the state of New York for a brief period of time in the fossil record, a direct indicator of both species living side by side at the same time. Fossil evidence also showed that within this isolated pocket of trilobite that it was the parent species of trilobite and had evolved into the descendant species of trilobite that came to having only 17 raised lens units that made up its eye. For 3 million years, there was two different species with only the slightest morphological variation, as mentioned, living side by side one another. This whole scenario that happened was a case at one point of two related species of animal living side by side one another, and also a case of animal migration because of environmental change, not situations of slow and gradual Darwinian evolutionary change of one trilobite into another. Based on discovering all this, Professor Eldredge would come to call his new theory punctuated equilibrium. In this case, where a trilobite with 18 raised lens units in its eye, rapidly evolving into 17 raised lens units within its eyes, then the rapidly developing species and or parent species, as it is known, dying off and leaving the descendant species that is morphologically similar in so many ways, except when it came to their eyes. Then from there, a species left to exist without any morphological changes, staying that way for millions of years.